Hi, my name's Han. We're going to be talking, this is Merrick. We're going to be talking a little bit about transactions and batch rights in Kubernetes today. This is probably one of my favorite topics, and if you guys think that I'm going to implement transactions for you within the space of this talk, then I'm sorry, you're going to be a little disappointed. What? Why is this not working? There we go. Because that's not going to happen. However, what I would like to frame this conversation as is how would we unlock an order of magnitude improvement on rights in Kubernetes? And when you think about this question, it seems almost necessary that we would need to have batch rights for this to be possible. It is a necessary but insufficient part of the solution to have like 10x more rights. So why can't we have batch rights or transactions in Kubernetes today? It's a great question, and we're going to answer that. But first, we're going to need a little bit of context. And once we go through that, we're going to try to answer the question, can we hack around these limitations? So Merrick is going to go into a little bit of context and history for you guys to understand why we can't support transactions or batch rights today.
Okay, hey. So one of the more unique things about Kubernetes is compared to most other databases of storage that we use, it allows, or it optimizes for controllers being able to view the state of the world and be able to act on it. This results in a pretty different access pattern that requires us to use a pretty different protocol. And this is, as you might have heard about, list-watch protocol. It's a protocol that optimizes the path where instead of controllers trying to continually list to see what is the state, how it differed, a controller can just ask about the state and then subscribe to all the history that is changing. And this poses a lot of more constraint than on what we can do than in any other system. So let's look at the watch, specifically the starting from Kubernetes watch. You always start from the list, and you can list based on. Can we grow it? Okay, thank you. So you can do a different type of list request. You can request a single object, a namespace, or even entire resource type. And you will then get a response that is a snapshot of the state with some resource version attached to it. It will be the resource version that was used to, at that time, that was used to generate the results, so the newest version that was available. And then you can use this resource version to open a watch to then to get a stream of events, each of the create type or update version, and you will get a resource version for each of them so that you can know how up to date you are and how we can react to it. Also, for performance reasons, Kubernetes supports so-called bookmarks, which can give you continuous updates how you are progressing. So that's when something breaks, you can not necessarily restart from the beginning, but somewhere much later. And the protocol handles or needs to describe a disconnection. And during the disconnection, you can do two things. You can either start from the beginning and do a new list, which can be expensive, or you can just continue from the last observed resource version. And this is a pretty simple protocol, and it's not technically something unique to Kubernetes. So if we look at differences, what it is different than what you can do in etcd, there is just a couple of minute changes. You can use, instead of doing a list, you do a range, which now which limits you or put a limitation on Kubernetes that all the objects that you can really list in Kubernetes needs to be a continuous range. And instead of getting you a resource version, you will get back a revision. So this revision in Kubernetes maps one-to-one. So Kubernetes just returns the revision returned by etcd. And the same way you can use the revision to open a watch request. What is maybe unique about etcd is that instead of getting a list of events, you get batches. You get a response that can include multiple events at the same time. So this will be important in the future. Instead of a bookmark, you will just get progress notifications, and all the other things fit one-to-one to the protocol being very similar. So if we look at the response, or in etcd, we will get a repeated set of events that can be updates to the objects. So there can be multiple, like from 1 to even hundreds of events within a single response. While on Kubernetes, it's much simpler. If you get an event, it can be either added, delete, or a bookmark. And for every of those, event, you will get one runtime object. And runtime object can be, usually it's, I think, it differs depending on the event type, but it can be just at the end one Kubernetes object type. And this poses a big difference on how we can do batches, because in etcd, it has a full support for multi-object transactions. You can take 10 different pods and update. If you could support subkeys, you could just update 10 of them at once and get the same transactions as you would do in Kubernetes, just on 10 objects at the same time, getting the 10 times bigger throughput, because all these transactions will be considered done automatically with one write to the disk. But on Kubernetes, there is zero atomicity. So there is some support for batching, but this requires, this is just a promise or a lie that Kubernetes just give you a promise that you can do a batch delete of collection, but underneath, really, this is handled by multiple independent transactions. And one of the reasons is when you match, when you compare watch and implementation between etcd and Kubernetes, the etcd transaction will return multiple objects with the same revision, while on Kubernetes batching, you will get multiple objects with different revision. And this becomes when you think about the guarantees on the watch. So in both cases, you expect that watch will return you an ordered stream of history, what happened, that each event there will be no duplicates on the stream, and you will not lose any information, so it's reliable. And if something breaks, as we discussed about cancellation, you can resume it, and you can ask for bookmarks, so you'll get updates even if nothing happens. But the main difference is the atomicity. On etcd side, you will get, if you send one multiple batch transaction with multiple objects, you will get one watch response that will include all of the changed objects that will share the revision. But on the Kubernetes side, you cannot do that because it doesn't, each event will be a separate, or each transaction will be a separate event. So if you try to use the same revision for them, things will not go as wrong because it will be not atomic as a response. So this goes into the discussion that can.
Yeah, so thanks. So yeah, we have some key differences in our protocols. Specifically, in Kubernetes, the watch event can only contain a single object. Only a single object. So this wasn't actually common knowledge, but we're going to go into the fact that we cannot have objects sharing the same RV in Kubernetes without it invalidating our protocol. we're going to show this by a proof by contradiction. So we're going to start by assuming the thing that we want to disprove. And then we're going to show that it can possibly lead to an invalid protocol. So the thing that we want to disprove is that we can, in fact, share an RV across multiple objects. So let's assume that we have 5 objects. They all have the same RV. So we've batch written them, right? Now, if we have a watch open, we've already done our list. We're streaming now. And we observe one of these writes, right? We're supposed to get a bunch of watch events. Each watch event has a single object. We only see the first one, and then we get disconnected. We know that that's possible. Then we reinitialize the watch, because that's what our protocol says, right? We take our last observed RV, we plug it back in, and we say, let's resume our watch. Internally, the API server does this. It actually takes that initial revision and it increments it by 1. It parses the RV and increments it by 1. So if we're sharing the same RV across 5 objects, then that means we're going to skip. That means the 4 other objects are just going to be skipped over. We're never going to see them. So imagine that we have 5 pod creations. We see one, and then we skip the rest of them. Obviously, the controller is not going to be behaving correctly. That means our protocol can't be correct, and that means that it is actually invalid for us to be able to share RVs. All of this because the Kubernetes watch event, when we first designed it, we made it limited to a single object. Now, this is like standard API design 101, right? Like, use a list, don't use single objects, right? Yeah, in this case, we messed up because we should have used a list. That would have, and if we didn't want to support batch at the time, we could have just had a list and just sent one object all the time. But we kind of shoehorned ourselves here. So one of the things that I've been thinking about this problem for years, frankly. And one of the things that occurs is, why can't we just create another watch protocol, right? Why can't we just create a watch v2 and just fix this error? We could do that, right? This would be inordinately expensive, and it would not be backward compatible. And when I brought this up to David Eads, he very politely, very gently, and very quickly shut it down. So yeah, not super viable. But there is a loophole. There is a way that we can get around this problem. This is our official stance on RVs. RVs are supposed to be opaque. We're not supposed to assume any order, right? That means that to any client that is behaving by the rules, they should only ever be passing back the RV that they last saw, and it's just an opaque string. That means we can do stuff under the hood. Unofficially, the RV is an etcd pass-through, right? The RV is a 64-bit integer. And each of these things from the etcd documentation shows another important attribute about the RV. Interestingly, in etcd, the thing responsible for incrementing the revision is actually the client and not the server. So the RV is not opaque to etcd. And you are responsible as the client to be able to ensure that you can either handle duplicates or that you are incrementing the RV. It is the responsibility of the client. So can we change the RV safely? Here's the thing. When we changed the protocol, when we said the RV was opaque, that was a deliberate choice from the Kubernetes community. Why? To make it possible to change the RV. That was the point of it, right? Otherwise, we could tell people, just increment the RV, it's an integer, incremented by 1, API server will just do whatever you say, right? We reserve this functionality, specifically so that we could change the RV. Now, what does this mean in practice, though? Violations do happen. There was a survey. Steve Kutsanoff, I believe, did this resource version parsing survey when he was investigating stuff like this for KCP. And violations of it do happen, but they're very infrequent. And again, only occur when people are doing something which we explicitly tell them not to do. So what could we do with the RV to fix this? So given an RV that looks like this, it's possible for us to do something like this, right? We could add the index of the batch. So if we have more than one object that shares an RV, we could add the index of that, and that would allow us to continue to increment and to observe, to maintain continuity without skipping objects. We could also do this. We could bit shift and add the index. And this has the additional property that just adding one works here internally in the API server. Yeah, if anyone is doing some client-side parsing, this would break because now you don't have a 64-bit int, and now you have a 128-bit int. However, they're not supposed to be doing that in the first place, so. We could even go crazier. We could actually just make it completely structured and just do a little bit of string parsing. We could version it so that if we ever needed additional stuff, that we could add it. But this isn't enough, not in order to get 10x write throughput. Why? Because we're still writing the entire object, and so the amount of data that you're sending to etcd would be constant. So splitting spec and status and metadata as different objects in etcd could probably help there. What else could we do? If we were to ever introduce something like this to the RV, we would have to be very careful about introducing it, because now you have two different types of RVs. So what you could do is you could introduce this new type of RV very slowly. You could introduce being able to read the old and the new version of the RV for the entirety of supported version SKU in Kubernetes for like 3 releases or 4 releases, and then switch over writes, right? That would allow you to support everything once you start writing, everything that's supported. Yeah, so again, this isn't sufficient for 10x write throughput. Splitting up the object is probably something that we'd want to consider. But yeah, in order to support transactions, we would need to support multi-object writes. I'm not even sure that we want to support transactions, but batch writes definitely feels like something that Kubernetes is likely would want to support in the future. So yeah, I'd like to open up for questions if anyone has any.
Hey, so 2 quick questions. I think the first one is you quoted the need for batch writes. Are you thinking more for like controllers that are trying to create, let's say, too many pods at the same time, trying to optimize for that? Or and the second question is you've talked about the flexible RV string. Could that possibly also be used like a vector clock to aggregate information from multiple API servers and render them in one place?
That's a complicated question. Okay, so. All right. Wait, can you repeat the first one?
Why do we need the batch writes?
Well, I mean, atomicity, right? Like sometimes you want atomicity over response. Second thing is, if you want to improve write throughput, then basically you want to make the object smaller, the things that you're writing smaller, and you want to be able to batch all of them, right? And then you probably also want a more efficient watch response, right? So, so improving your ability to actually stream diffs as opposed to entire objects is probably something that we would want. And the second part of your question was vector clock, I think?
Yeah, the second one was about like using the RV string format to potentially, aggregate different API server responses in one place and present them as vector clocks so that you can still rely on the total order as different API
I don't
servers.
understand, like, what do you mean by different API servers?
Like imagine you can build a read-through proxy that queries different APIs, fans out to multiple API servers in the backend.
So you're talking more like KCP. I
Yeah,
think
similar to KCP.
I'm not sure that this is something that would be supported internally. I feel like something that you're describing is like a multi-cluster concept. It would be built on top. Yeah, I mean, it would probably be built on top, and then you'd have to have different types of controllers that actually did this, I think.
So I have two questions also. Like the first one, like, do you think if we just say RV instead of being an opaque string, it's an integer, does it make things easier?
If we make it an integer, like
Yeah.
if we actually don't make it opaque,
Yeah.
then we don't have the ability to change anything. That we're kind of shoehorned into the pass-through. Like it just becomes the global revision in etcd.
Right. The reason I ask is like, so I worked on the storage version migrator that got merged into 130, and it's an alpha right now. And we essentially moved out of tree API into tree, but
That's right.
the controller was rehauled. And one
Yeah,
of the
right.
assumptions that we made is
That it's an integer, yeah.
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 And I'm sort of trying to get that through, like, let's say if that goes through or not. So like that's one of the requirement for beta and
I
other
mean-
graduation. So does that, if that goes through, like how does it change the dynamics?
We're very fortunate with the storage version migrator that we control that code.
Right.
So if we do change the RV, then it's on us, and we can actually change the way that we're reading the RV. So we can support, reading a more structured RV with multiple component parts, right?
Right. And maybe this might be a follow-up discussion. Maybe I'll just reach out to you. But what I saw is the complex RV part that you listed over
Sure.
there. That's not something that like I had proposed, like something like this. It's just like this is an opaque string and we are converting into an integer. So maybe we should probably just think and see like if it makes sense to do it like this or
Like this.
or just the proposal right now in SVM is just convert or parse that to int.
Yeah, I mean, here's the thing. If you have something like this, you can have a sorting function, which just takes these parts, right? And then returns whether or not it's
But
greater or less
then
than.
the parsing of this would be
Yeah.
this would be like the custom parsing function that we have to write.
Yeah,
I'm
sure.
just suggesting,
Sure.
what I'm asking really here is, like if we have some requirement like this, for example, for this case, then maybe we'll have to come up with some general consensus as to what we want to do.
I mean, generally, we're not supposed to parse the RV. But if we were to allow people to parse the RV, then I think we should provide a client library that one just used. But the problem with this is obviously you have to support many languages, and it becomes it becomes a thing. Yeah.
Right. Yeah, and I think the other part with the SVM, since it's now part of KCM, will probably be officially saying or officially defining the meaning of RV, right? So good to probably just think and.
Yeah, I mean, we're not really changing the meaning of an RV, though, because it's an opaque string, right? So, as the client, all it's supposed to do is just take the last observed RV and pass it back into watch. That's the protocol. And as long as the client is doing that, whatever we're doing under the hood is fine.
Yeah. Consider continue token, it's just a base 64 encoded JSON, so clients should not, it was
They don't parse it,
explicitly
yeah.
encoded just for clients to not even try to
Okay.
understand it.
Yeah, I think let me sync you offline. I think there is some gap in my understanding maybe, but I'll reach out to you guys afterwards.
Tell me, Han, why can't we just fix the +1 problem?
What do you mean, why can't we?
You said in the code we add 1. Why Why don't we not add the one and just, you know, if you asked for a revision, you might get a duplicate of the revision, but at least you're guaranteed not to have the edge case.
Well, it's hard to say whether controllers would act the same way. And it's possible to implement controllers without using stuff like client Go. And so duplicate handling would have to be handled by every client. And that's a change in protocol.
Because we don't guarantee no duplicates
Yeah,
today.
we don't do that.
Or
Yeah.
sorry, we do guarantee no duplicates.
We do guarantee no duplicates, yeah.
Seems like that was the mistake.
Yeah, that was a mistake too, yeah. I mean, it's a mistake in either dimension, I guess.